In this video, we are going to talk about vectors. By standard definition, a vector is a directional line. But what vectors are and why do they exist? Where do we use them? Let's take weather forecast. When they say, for example, the northwest wind with 18 meters per second. So we can say that there is directional information, right? Northwest. And there is a modulus, meaning absolute value of speed, 18 meters per second. Quantities that have no direction are called scalar values. So vector consists of scalar value, we can say. Okay, for example, what other scalar values can be? Mass, work, electric charge. They are not directed anywhere, right? They are characterized only by numerical value. So physical quantities that have not only an absolute value, but also direction, but also a direction are called vector. So scalar value, absolute value, plus direction, that what makes vector. Velocity, force, acceleration, those are all vectors because have direction. Velocity, you can drive one way, it's positive. You can drive another way, back, it's going to be negative direction, right? Meaning opposite direction, I mean, right? Force can be all kinds of direction. Let's say you have some object, so force can be from this side, from the bottom to the top, and so on. So force is also directional, correct? So for elements, vectors like that, how much is important and where is important, which means both of them are equally important, and scalar value and direction. Okay, so how we mark down a vector? Vector can be written down the following way, the notation. AB, okay. It can be written down as AB like that. It can be written down BA like that. The meaning between all three, or it can be written down as a vector like that or like this. So what is the difference and what's similarities? The correct way to write down it's when you have arrow on the top. But for the easiness, people sometimes put this line on the top, and that also indicates that we're dealing with a vector. Now, every vector has a beginning and the end. So how do we know where is the beginning and where is the end? If we have AB, let's say with vector, let's say this one, that means A is a beginning. First we put the start, and B, it's going to be the end. Okay? The same way with these cases. In this case, it's also going to be A, same way. This is B. But when we have BA, this is how it's gonna work. This is B, this is A, or to make it crystal clear, I'll put this way. This is B, starting point, and this is A, meaning heading opposite direction, right? And A with arrow on the top, we just put the vector A like that, or like this. It's the same meaning, all these notations. So one thing with two uppercase letters. Oh, the other way also, in the typings, in the textbook, you can find it, vectors written down in bold letters without any lines on the top. This is also mean the vector, okay? But that's in the typings, in the books, you can notice that. In the writings, we always put some arrow or some line, which means we are dealing with a vector. The length or modulus of non-zero vector AB, length of, or modulus also, it means length, AB vector, is equal to length of segment AB. Okay? The length of zero vector, by the way, which vector we call zero, where end of vector coincide with the beginning of beginning or starting point of the vector. It's a length of segment zero. Okay? And the vector length indicated by the module mark, meaning absolute value, AB, or it can be absolute value of A, let's say. Okay? Okay. So now let's take the following vectors I have prepared, so not to spend time on drawing here. What are what these vectors are interested with? They are interesting because they have the same length, and all four are laying parallel, meaning in the same direction, right? So usually they call as an equal vectors, okay? But mathematically, from purely mathematical point of view, this is the same vector, and we call it as a free vector. Free vector is used in the space, 3D dimension. So I will cover all this when I'll go into vectors of 3D dimension in the space. But now I'll just tell you that two vectors are said to be equal, or also we call it as a free vector, if they have equal module and are identically directed. Okay, so this is free vector or equal vector. All right. All right, so a free vector is a set of identical directed segments. Okay. A vector is called a unit vector if the length is equal 1. We have unit vector. And if the length of the vector is equal 0, as I already mentioned, we have it a 0 vector. Okay. Now let's talk about collinear vectors. Collinear vectors. Collinearity of vectors is meaning these vectors lay in the on the same line or on parallel line, which means while in the math, in algebra, we call or geometry, we call lines are parallel. In the world of vectors, we are going to use the word collinear, okay, collinearity. So here, those vectors. So even if this one's free vector, you see, you can take a set of collinear vectors. This one's also a set of collinear vectors. They are laying on the same line. If I take two parallel lines, let's say, this one, and on this one I'll build this type of this length of vector. On this one I will build this vector. They are gonna be called as a collinear. I can even build opposite direction vector, and they are still gonna be collinear. Why? Because these vectors are laying on the parallel lines. And here is also, you can see on this picture, they are collinear, all these vectors, because they are laying on the parallel lines. Okay, so what do we have on this picture here? A is equal a square root 3, vector A, but the vector A is equal negative vector A. So those are scalar multiplication, product. We multiply vector by scalar value. So let's say here is our the length of vector A, right? So which means for this one, it's gonna be equal. What do? We took square root 3 and multiplied by vector A. So practically the length of this vector, this one, is greater than it's multiplied by more than square root 3 times. Okay, now in this case, this one, you will see it's a same length vector A, but goes opposite direction. Therefore, we have negative sign because it's a vector, so direction can be different. This one, vector B, is a half of vector A. So if you take it, it's twice as shorter, the length. And here you have vector C. Vector C, that is twice as long as vector A, but opposite direction. Therefore, we have negative sign. Since vectors can be collinear, that means there should be vectors that are perpendicular, right? The word perpendicular in the world of vectors we call orthogonal vectors. The best way to show these orthogonal vectors is to draw in Cartesian coordinate system. And I'm going to show in Cartesian coordinate system in space because it's easier, better to understand. So what is Cartesian coordinate system in space? We know that on the plane, we have two axes, right? X and Y. But in the space Cartesian system, it's called as a triplet of mutually perpendicular axes intersecting at a point that is called origin. Okay, this way, this, and this. So this is Cartesian Cartesian coordinate system in space. And where x is moving here, y is moving here, and this one is going to be our z axis. All right. Where x we call abscissas, and y we call ordinate, and z we call applicate. So let me write down and abscissas, okay, ordinate, and applicate. So the Cartesian coordinate system in space, it's the same our rectangular coordinate system, or we call orthogonal coordinate system, okay? This system also we call orthogonal. So what is next? We already know that unit vector is the vector that has the length 1. And unit vector directed along the x we call as I. Unit vector along the y axis we call j. And the unit vector along z axis we call k. Since those are unit vectors, that means their lengths are 1. And this, the vectors I, j, and k are called orths. Let me see. Let me write down, this is k, and this is j, and all three, this I, j, and k, we call orths. Okay? And they have single modules. I is equal 1, j is equal 1, k is equal 1. And we can say that I is orthogonal to j and orthogonal, or we know that's a synonym to perpendicular, correct? K. Now let me show you how we're going to use this I, j, and k. Okay. So, oh, I don't want this black one. Okay, I don't need to hold this thing. I'm going to show only 3D dimension. There we go. Okay, so Okay, so this is our X. Y and Z, our 3D dimension. So let me put there I, J, and K. So let's say this is our I. Okay. This is our J. Has to be same length. Okay, don't judge me strictly. I'm doing approximately. It's supposed to be same length, which is going to be 1. Consider 1. And K, I think blue one could go a little bit further, huh? Okay. So now let me draw the vector. So this is J, this is K. Okay, so how I'm going to add them, these three? I have here vector V, V1, it's gonna call expanded vector V2, this is V3. Okay, so all right. Not bad. Let me clean this. Nah. I was going to boast already and I messed up. Okay, one more time. I think maybe I went too far. Okay, this is our V3 vector. Okay, and lastly, good job, huh? I can't say one word, immediately messing up. Okay, that's it. I'm not going to take your time. Here we have. So which color to take so we can show it bright way? I don't know. Let me take this one and thick. This is our vector V. So vector V is equal V1 times I plus V2 times J, because this unit orths are vectors, right? And plus V3 times K. So this vector we wrote down in the expanded form. Okay. I think this much information is enough. I'll let you digest what you see, and then I will deliver operations over vectors. So, but first I need you to understand all this, so it will be easier to work with vectors further. Thank you very much. I hope you like it. And if you like it, put likes so I can see you enjoy the video. Okay, see you again. Bye-bye.